Let's talk about the architecture. So how does Global IDs work? So it's modular in that an initial base installation involves a server and a metadata repository. Those are generally two different machines as you're trying to scale up. And that it's agent-based in that work is parallelized through software agents that run within environments that we call habitats. And you can think of those as containers, much like a Docker container, but it's our own internal environments for these software agents to run. That it can be scaled by adding more servers to run more of these agents in more habitats. And so that's what the dots represent. These agents are specialized so that they can perform specific tasks. So when we're doing profiling, that what we find is that there's certain agents that can do discovery. There's certain agents that can go in and inspect columns to identify the shape of a column. There are agents that know how to correlate things. There are agents that know how to group things into domains. And so there's workflows that run in our controller that schedule agents, and these work independently. The next level here is that the agents can perform different types of analysis. So not only working on structured information like relational databases, but they can work against graph databases, Hadoop environments, LDAP, unstructured text environments. Of course, what you find is that the metadata that you can extract from, say, a PDF is not always the same as what you can get from, or it's rarely the same as what you can get from a relational database. But to the extent that it can, it attempts to try to map data into an internal tabular structure. So what does that mean? That if you were subscribing to a Kafka queue and what was coming across that was XML data, you wouldn't necessarily have a schema for it. So you could look at the XML tags and you could begin, as you see multiple records come through, you can begin to derive some sort of a structure that says this looks like a table, this looks like it might be a subtable. You're not entirely confident that you have the full schema, but the more that you inspect, the more you can do it. That's generally the approach that Global IDs takes as it looks at these different types of data. It tries to put it internally in a table structure so that it can run the various types of profiling consistently across them. That enables it to look at data in a graph database or data in a Hadoop environment and relate it back to data that it finds in a relational database. So how do we provision it? There's a number of methods that most of our customers use dedicated servers for their environments. That there's a server for the main controller, there's a server for the database, and then there's some number of servers for habitats. You generally want to have your habitats close to physical databases. So if you're in an environment where you've got 2 or 3 data centers that are spread across the globe, you would place your controller in one location and you would place habitats close in those other databases, other data centers close to the environments that you want to profile. Another option is to use on or off-premises cloud. So if you're in an environment where they've got OpenStack or Apache Cloud Stack, that you can elastically allocate habitats as demand increases. So maybe you can only profile weekends and off hours. There's no sense in having dedicated hardware sitting around if you're only going to use it a portion of the time. So those are ideal use cases for enabling cloud. There are customers that are actually moving some of their environments into the Amazon cloud, and so in those cases it makes sense to be able to run in Amazon, and to be able to profile those databases that they've, for example, Redshift or other forms of databases that they've moved up into Amazon. We also provide options to run them within Docker containers and also within Hadoop, so that you can have your habitats running inside the Hadoop environment. I think the next slide is probably more instructive. So in this case, we work with Apache Slider and use that mechanism to orchestrate allocating habitats as needed using yarn. And so it works the same way. These habitats are running in here. The data is fed back to a central metadata repository where the analysis is aggregated. We can go to larger environments, going to a federated environment. And so this is a picture of a large federated environment. So in this case, we created child systems. So each child system looks like one of these. And in this case, we had 288 of them. They're spread across 12 different data centers. And we're scanning 35,000 databases, plus there were 5 Hadoop clusters that were distributed across different data centers. Each of these environments collects their portion of the metadata, and then it's brought back up to the central metadata repository where you can get comprehensive views of the enterprise. All of the workflows that involve doing inspection or monitoring of quality are orchestrated from the parent and dispatched down to the children, where they each have their own habitats and they each schedule work and they run in parallel. So as you can imagine, this is a massively complex or massively parallel architecture. So I'm going to pause there to see if there have been any questions before I move to a discussion on the API. Gary, I don't know if anything came in on the web or not. I don't know if I'm still on.
Well, you're on. There's a question that came in related to data quality. And the question that was asked was, as part of the data quality, the rules, can the rules be defined? Based on the rule, can the data be profiled? So does Global IDs have a facility to tag a value based on the rule and store it? For example, if I define a rule, arrive at a Boolean value, true or false, can I save the Boolean and then do data profiling on the data set, including the new Boolean value per record? So Bill, can you take a shot at sort of how we deal with data quality rules? And I think the Boolean value, the question about the tagging, maybe we can have a sort of a separate conversation with the author of that question and just explain how the whole thing works.
All right, so let me, so one of the things that we can start out with our domain verifier. So there's a number of different ways to define rules. So we can look at so here we've found this QSIP domain, and it's found a number of columns that have been mapped to it. So what we want to do is, rather than defining rules at each column level, we want to be able to define them at the domain level and say that any column that we've found so far must conform to this set of rules, and any columns that get found through subsequent matching or profiling that get matched into this domain would then also need to conform to the same rules, is what it's saying. That our rule base uses a number of different techniques. So you can use regular expressions. So these were derived through the profiling that it found this set of regular expressions, and the human can go in here and add more or remove ones that it believes are invalid. But these are essentially saying every piece of data must conform to those constraints. There are also rules over here, such as does not have special characters, does not have digits, and by checking these boxes that you'll get those rules to be applied to that domain. You can also import reference values. So for certain domains, you might say, these are the only possible values that can be here for a US state code, and so you can import those. You can pull them in from an external Excel, or from a column, or from files. You can also point back to, you can say, this particular column in my environment is the master column, and you can point back to it and say everything must conform to that. And we see customers that do a lot of this to say that here are my master data sources, everything else must conform, and it'll find verification errors that say that these things are because they're lagging, don't necessarily have all of the values, or they have values that are not found in the reference source. There are other rules that we can create that, I don't know if this will necessarily answer your question, but it may give you an idea of what, so we can, we can, so we have what's called a business rule manager, where we can create descriptions of rules. We can give a business description to it. We can have a user define in English what it means for this rule, because what you find is that you have situations where the business subject matter expert understands, they can describe in English how what it means to be valid data, but they're not in a position to be able to translate that into what we call SQL rules. So these can be converted into expressions, which can then be mapped onto columns, and we can apply different custom attributes to the rules. Dr. Mukherjee, did you want to add anything about the rules?
Bill, I think that's a good overview, but I think what we are trying to say is, just like models, right? You can look at models from a conceptual perspective, a logical perspective, and a physical perspective. Rules can also be looked at from a conceptual, logical, and physical perspective, right? So Global IDs has the capacity to put the rules in these three formats, and then take the physical rule and map it to wherever it exists in the ecosystem. So let's say, for example, in the example of, let's say we want to find, we found this use case in a particular customer. They're a bank. They want to find out all the date of birth columns across the whole ecosystem, right? And then you might have a rule on date of birth saying that you can't have people who were born before, let's say, 1900, right? So that rule, if you put it in, how do you know you can run the physical rule against all the databases that exist? Because the data may exist in an Oracle database, and so you have to run a rule in PL SQL, and then it might exist in Sybase, and it might exist in Postgres, and it might exist in Hive. So the physical rule has to be mapped to different SQL dialects, so that the rule can be applied at the ecosystem level, right? So these are all the complications associated with managing a rule base for the whole ecosystem. Global IDs has many of those capabilities. The specific question that was about putting a Boolean tag, we have to understand that use case a little bit better. So whoever asked that question, if possibly you can just either stay on or just send us an email, we'd be happy to sort of discuss that specific use case with you. All right.